our next speaker in this session is Karla Štěpánová. So Karla is a researcher here at the CIIRC at the Czech Technical University, working in this building. And she's working in robotics, doing some very nice work in imitation learning. I guess she'll be talking about some of that today and building her own team in this area here. Karla, the stage is yours. Thank you very much for coming.
Thank you for a nice introduction. And I would like to also thank everyone for interesting talks yesterday, which were already inspiring part of the talk, as you will see. And today I will talk about verbal and non-verbal communication and how we can use it to control robots or teach them some new tasks. And coming back to yesterday, if there was the question if speech recognition is over, I would say that in this area, the question is a bit more, has it already started? Because if you see the number of papers which are coming recently, every year out, there are like hundreds of them, and it's incredible amount, and it seems like everything is already solved. But when you come to the real world and see what has been done and applied in SMEs or in industry, then it is not there yet. The SMEs and the industrial people, they have high expectations what can be done, which is totally not matching what we are able as researchers to deliver, because the models are not robust, they are not able to have accuracy which we would need for the real application, and they are having, especially these systems which need the communication, they have very big delay, so they are not as useful as they should be, and they are slowing down the industry. But the industry would really love to have some intuitive way how to teach the robots new tasks, because it would enable them to quickly change the tasks and avoid the costly reprogramming. Okay. And I will focus on subset of the area, and I will talk about how we can use language and gestures and demonstrations to teach different things, and language in the simple way, which is already used in many devices, in cars and also in industry, can be used just to command the robot. You use some templated actions which are connected to pre-programmed robot motions, and then you are detecting from the language which parameters this action should have. Anyway, if you want that the robot is really able to adapt to new situation and understand what you are meaning, but what you are saying, you need to teach the robot. So for example, you can teach him static properties of the objects or dynamic, like showing him different actions, naming them, and then asking if it really understood what color is the object, what action was performed, and so on, which is getting more challenging. And when we come to gestures, then similarly, we can use gestures just in a very simple way, where we use them to control the robot and trigger some pre-programmed robot action. And these actions can be either pre-programmed or learned by demonstrations. So you can use kinesthetic teaching, some tracked tool, or teleoperation, wearable devices, and so on. But it's always a very restricted area, very restricted set of motions, and given set of templated language or templated gestures. We would like to go further to really make it working, and how you can go further. Josef Šivec will talk about it very soon, is that you can use a lot of instructional videos from which you can learn, but you can also use the real demonstrations, which is the important part, where you are really tracking the device and putting together the demonstrated motions and the positions together with language, because not everything is visible in the camera, in the vision, so you can't see the force which is applied, you can't see properly when things are overlapping, how it is done, if it is screwed 2 or 1 centimeter inside, and so on. All these parameters can be easily specified by language. The problem, of course, is then that you have to synchronize the different sources of information. And when it comes to the learning, then if you want to teach the robot new task and name these tasks, then you can also teach overall body movements. And what we would like, again, is that when you are teaching the robot, you don't need a huge amounts of data, but you can rely only on few demonstrations, on few movements, and it can easily learn because we don't have infinite data as Google has for the vision data sets and so on. One last thing to mention, it's really important to provide benchmarks which would be suitable also for this embodied reasoning and for this real applications, because we have a lot of benchmarks for vision, we have a lot of benchmarks for speech recognition, but we also try to introduce some benchmarks which would allow to verify how the methods are working actually on the real world data sets. And when coming to the mapping and learning, there is also need for benchmarks which would be explainable and where you could explain which of the knowledge is already available in the system. Because we have like the amount of new works is so huge that there are coming new algorithms, and they always introduce basically also new data set to show their strengths in the area. And they not always verify them on some unified data sets, which is of course not possible because the data sets are very often not available. So what we have done in the area and where we see the challenges and the discrepancy between the industry expectations and the reality, we have this collaborative robotic workspace where the robots are supposed to work based on the commands given by the user, and in this simple setup the language can be used to command the robot or set some amount of feedback coming from the system or selecting which task is supposed to be done, and all of this works quite nicely, although it's not maybe as quick as it should be. There are several challenges still coming even from the vision. For example, if you have same type of objects stacked on top of each other, it's difficult to distinguish the borders and so on. But it's getting better. The bigger problem is the synchronization with the knowledge base, which you have to all the time basically update based on the real observations. Because if you see the papers, they often present results on very nice setup where maybe they move some object to change the conditions, but then there is enough time to adapt to the situation, and there is not real cooperation between the human and the robot, in the sense that human is moving several pieces and the robot has to react and understand what was the command. Similarly, when it comes to the gestures, I said you can easily use them to operate the robot, and you can learn different types of gesture, either dynamic or static, and then these gestures should be basically recognized in parallel. So you might show a sequence of gestures to specify parameters of the robotic action. You need to show the gesture which is able to specify, for example, end and start of the robot action. And all of this has to be recognized as a sequence which comes together and specifies basically one robot action, which is the challenge again. If you want to show start here, move to the right, place it here, do it and then close the gripper for this size, and in parallel you have language coming with the gestures showing you the task, and then you want to put it to the real robotic platform, it becomes challenging. So, however, even the gesture language can be extended when you can use different like both hands, for example, if you use the context of the situation, and if you take into account that for example, the similar gesture might have different meaning in different situations and for different people. So all of this, if it is adaptable and can be learned, then the expressiveness of the language, of the gesture language, becomes way higher. Here is the one option how the demonstrations together with the language might be combined. So you can imagine that you have some set of instructions, and next to it you have demonstrations where is demonstrated the position and the type of task. And then after processing these two sources of information, you get a description of the robot program, which can be optimized and applied to the robots. So you have some set of tasks, set of constraints on them, set of locations, description of places, and then you can use some planner and scheduling to find the optimal solution when applied to the robot. And the last thing, or one of the last things which I would like to mention is the need for learning and understanding actually the thing. Because all what I mentioned so far was basically you have templates, you know how the word is looking, you have a set of words, you have a set of gestures which you can use. But what if you don't know the word? What if you are supposed to learn the domain where you should work? So there you have to basically learn from just the experience, where you get the linguistic instructions, like description of something, you have some observations, and you have to find the mapping between these two, between the features in the visual world and the words itself, and find the assignment between these two domains. This is very old pre-neural network model. Now all the modalities are basically exchanged for deep neural network, but what stays and what is still difficult is how to find actually the mapping between the domains out of the very simple cases where you would have just an image and some simple description, where you would have a realistic environment which is not synchronized, and where you have to deal with the real world. So we have some very promising and good results and impressive outputs of the AI solutions. However, they are still far from being really embodied and working in the real world. The way how to take the recent advances basically in AI, especially the transformers, to the real world, we tried to use the variational autoencoders to teach the robot some simple actions and see how it can learn from few examples. What is the problem here is, of course, that the robot should keep the knowledge of the classes which it already learned before and keep them even when it's learning new classes. And here you can see the performance after just 5 or 20 training samples where the robot has no knowledge before about the movements. And if you use a naive approach, when you would not have some nice generative replay, then of course it forgets the actions which it learned before. So you can use the generative replay to avoid forgetting, and after 5 or 20 samples, it can still then add more and more classes basically to the knowledge. I will skip this, and I will talk about the great vision. So the great vision is that we can integrate these two parts together, that we can have a system which is able to learn new new actions, new models just from observations and from demonstrations, and find the simple model of robotic action. So it learns how to push, it learns robustly how to kick something, and so on. And it can apply it directly as a piece of knowledge when you use the demonstrations and linguistic instructions for more complex tasks. For example, you demonstrate how to set up a furniture, then you don't have to use anymore these pre-learned robot actions, but you are actually using the actions which are in parallel learned. So you are demonstrating the task, and the robot is in parallel improving its knowledge about how pushing works, what you mean by screwing when you say screw it here, and so on. And where we are now, to wrap up, so this is our one-year-old work, where we, together with people from Imperial College, were putting together linguistic instructions and visual scene, and the neural network is generating sequence of actions, which are then applied to the robot. And the model which is able to generate this sequence of action is basically based on mask RCNN, and then it makes some multimodal reasoning, and it's fully end-to-end learning in simulation and then verified in the real world. However, the action sequence is then applied to the real robot, which is having pre-learned action sequences. So still, we are not learning how to move the cube or how to rotate an object, but the loop is closing. And as I was reminded yesterday, there is 1 month old paper from Google who is where they are doing actually very similar thing, where they closed the loop, and it made me a bit unhappy yesterday evening, because in a week we were supposed to have a 2-week stay of a colleague and to implement exactly this finally in the real world. And so what the Google did is that you have a dialogue system, and you have a closed loop feedback where you are seeing the scene, and you have a fully learned language model which is actually also generating the inner monologue, like it's thinking what I have to do and deciding, okay, I got the task, so I have to do this, this, and this. So similarly, as I said before, it generates the learned language model, it generates the sequence of actions. However, when you observe the videos which they use and the environment, it's very restricted environment where you have a table with a few objects, you have a drawer, and it's learned in this restricted area where everything is nicely visible, predictable, it doesn't have any interaction with the human. Also, the human is sometimes moving the object to show the robustness. So this is where we are, and it's still far from what the industry expects, but I believe that we are getting there. And I think that I can end here, and thank you.
Are there any questions for Karla? Yes, please.
Thank you for excellent and really understandable presentation. Question: how many years we will need to reach the level of your of quality of your programming to the level we have seen in the film Terminator?
Okay, now there is a problem. I don't remember the movie Terminator. I saw it very, very when I was a kid with my mother. So but I guess that it was like just short, Schwarzenegger strong, and working for every command. Okay, I don't have an answer to this. It seems that it's moving, like now we have all the pieces. And that was, for me, this is like the step I saw it, like when I started the PhD, we didn't have the pieces. We didn't have the good speech recognition, we didn't have the good vision. And those are like basically the necessary pieces that you can start actually to build on top the understanding of the task and teaching and communicating. So we have the pieces, and now there is a huge focus of all the researchers to actually make this embodied reasoning and mapping. And I have no idea. I guess that in 5 years we will have something which already is applied in industry in specific areas, but it will still not be robust, adaptable. It will not be able to learn by itself in new environments. So it will actually work in the industry and fulfill what SMEs need for their tasks, but for the real, like it's about when we will have the general AI finally working, it's the same question basically. I think this needs the thing. You need that the robot is actually understanding, and I don't know, it can be 10 years, it can be 50 years, it can be 100 years, but not more. 2060, okay, then I made a good guess.
So we have one more question here.
Thanks for the talk. If I understood that correctly, then you're essentially learning from positive examples and sort of positive instructions. I was wondering how harder is it, or would it be to embed in your framework also instructions such as don't do this or don't do it this way, or whether there should be some active participation on the side of the robot in case of, uncertainty. What is and what is not allowed. And in principle, imitation is one thing, and then sort of generally prohibiting something. And you can show it on an example, but that still doesn't really capture the class of all the behaviors that are prohibited. So how harder is it to deal with that?
Okay. Thank you for a question. Yes, we are learning so far mainly from positive examples, and it's already difficult to include even I made a mistake and now correct it, even like for language, for synchronization, and for everything. So that's from my side like first step that we actually can correct somehow. To your question about the negative example, I think it's a great direction. Actually, with Ivana Krujf-Korbayová, we are writing a proposal exactly on this, because it seems to be the way how very often we are learning, like in parallel, and how it can be incorporated to my model or to our models. I don't know yet. We have like basically there will be some dialogue system next to it, and then I guess it will just have to be different model, and I don't know yet. But we can discuss it. And actually, one way, which is definitely the direction for us, is also the behavior trees and decision trees. So I like the talk because for the robot movements and actioning, it's great if you have this reasoning on top and you can decide and verify it. So I was very happy about the talk because I agree.
Okay, excellent. Thank you very much. Let's thank Karla again for the wonderful talk.